Okay, so let's actually make some graphs of rational functions. So right now, my graph, or excuse me, my example says r of x equals x minus 3 over x squared plus x minus 2. It's in polynomial form. What we should do here is take care of all of our y concepts first. So we're going to find the horizontal asymptote first, and we're going to find the y-intercept first, because this is the easiest thing to do. We haven't done any factoring yet. We can just use what we're given, and we'll take care of business. So we go to horizontal asymptote. Looking at the power on my x on the top, we have a power of 1 over a power of 2 on your leading terms. Top power is smaller than bottom power. That's case 1. Y equals 0 automatically. That's done. Y-intercept. Look at the ratio of the constants. Negative 3 over negative 2. Remember, we're putting a 0 in for all those x's. So that's 0 over negative 3 over negative 2, which is 3 halves. Or if you want to call it 1.5, that's fine too. Now that that's done, now we got to take care of the x's. So now we got to do some factoring. So the bottom has to be factored. The top is already a linear factor. So x minus 3 won't change on the top, but two numbers that multiply to be 2 and subtract to be a positive 1. How about x plus 2 and x minus 1? There's my binomial factors. Now that it's factored, we can find the vertical asymptote and the x-intercept. Vertical asymptote comes from the denominator, so x plus 2 equals 0 means x is equal to negative 2. X minus 1 equals 0 means x is equal to 1. Then we go to the numerator. This is your x-intercept. So setting this equal to 0, x would equal a positive 3. So we write that as the point 3, 0. And this does not have any holes in it because no binomial factors top and bottom are the same. So I have everything I need right now to make my graph. So my graphing order is as follows. You take care of the x's first. Vertical asymptotes and x-intercepts are plotted as your circles. Verticals are open, intercepts are closed. So pick any points you want on here. If you want to space it out so it looks to scale, that's fine. But I just randomly chose a couple dots here. These are like your tick marks on your x-axis. Here's negative 2. It's the only negative I have, so that's got to be furthest to the left. Again, this has to be in numerical order because it's a number line. It has an open circle. We have vertical asymptote at 1, open circle. We have an x-intercept at 3, closed circle. Now the next thing we do is we find your positive and negative regions, and that's based on your right-hand behavior. So what we're finding is where is the graph going to have positive y-coordinates and negative y-coordinates. So let's look back at the first terms. Positive x divided by positive x squared, positive divided by positive is a positive. You could also look at your factors in here. Positive x divided by a positive x times a positive x is a positive. So the right-hand behavior is positive. And because all of these circles have a multiplicity of 1, they only occurred once, your signs will have to alternate. So as I go from right to left, now between the 1 and the 3, these are going to have negative y's. My graph will be below the x-axis. Over here when it was positive, it'll be above it. After this circle, I'll be above the x-axis with positive y's. After the negative 2, I'll have negative y's. And once I've done that, we'll put in our vertical asymptotes right where the open circles are. And if you want, you could do the vertical asymptotes first, the circles, and then do the signs. That part order doesn't matter. And once that's done, now we'll put in our y concepts. Our horizontal asymptote is at y equals 0, and we have y-intercept at 0 and 3 halves. So here's my 1. So 0 has to be somewhere between negative 2 and 1. So I want to draw this out accordingly. So here's going to be my y-axis. Here's my 3 halves right on the y-axis. which is good because remember, this was a positive region. And my y-intercept is in a positive region, so that's good. And my horizontal asymptote, here we go, it's right over the top of the x-axis, y equals 0. So now it's time to graph. And you basically have to work with one of the given 2 points. I always like to work over here on the right-hand side first because I definitely know this is a positive over here. So what's happening is at this x-intercept, it must be crossing. It has to come down into these negatives, and as I approach that 1, I have to turn and head down, running right next to that vertical asymptote. And what happens here is once I go through that x-intercept, I'm not going to continue to go up because this horizontal asymptote over here says, hey, as you head out to positive infinity, you have to come back down towards 0. So I'm going to get a little speed bump right here. It wants to go up, and then it realizes, wait a minute, I got to come back down. So I get a little speed bump. So that's what my graph looks like right here. And then from my y-intercept, okay, here's my 3/2. There's no x-intercepts here to go through, so I have to have a U-shaped curve here. So again, as this y-intercept says, okay, I'm at 0 for my x, I'm going to approach 1, I have to turn and either go up or down. Well, there's no x-intercept to go through, so I have to turn and go up. Over here, as I go from 0 to -2, there's no x-intercept, I have to turn and go up again. So I have kind of like a U-shaped curve right here. And notice that when a vertical asymptote has a multiplicity of 1, one side of the vertical asymptote will go up, the other side will go down. So at this vertical asymptote here, since the right side of the vertical asymptote is going up, the left side must be going down. And oh yeah, that's right, I'm supposed to put a graph in this negative region here. And a lot of people forget to plot something here because there's no points. But you got to remember, we have to put something in here. So if I go up on the right side of the vertical asymptote, I'm going down. So we'll start here, we draw it, we come up, and we just make like an arc. Whoops, make your arc and have it run right next to that horizontal asymptote. And when you get there, just put an arrow. And that's true for all your vertical asymptotes. So you don't have to run right next to it for a long time. Just get to it, put an arrow. Get to it, put an arrow. Get to the asymptote, put an arrow. And it's all good. All right, next example. X squared minus 4 over x squared plus 3x. It's in polynomial form. Nothing's been factored. So again, we're going to do our y concepts, horizontal asymptote, y-intercept. We can do those real quick. Looking at the leading terms, x squared over x squared, the powers are the same. I have a 1 in the front of each x squared. So 1 over 1 is 1. The leading coefficient ratio is my horizontal asymptote number, y equals 1. My y-intercept, my constant ratio, I don't have a constant here. So I'm going to put in a plus 0, but -4 over 0, that's an undefined value. So there will be no y-intercept on this graph. So y's are done. Go to x's. Factor, factor, factor. We have a difference of perfect squares on the top, so that'll be x plus 2, x minus 2. And on the bottom, we can take out a GCF of an x to get x times x plus 3. Now that we're completely factored, the denominator, that's your vertical asymptotes, x equals 0, that's 1. Oh, that makes sense. If I have a vertical asymptote at x equals 0, I can't have any points on my y-axis because it's a vertical asymptote here. X plus 3 is equal to 0 means x equals -3. X plus 2, x minus 2 means we're going to have x-intercepts at -2, 0, and +2, 0. So we found all our parts. Again, no hole because no factors is the same top and bottom. So time to graph again. Plot all your x concepts. Close circles here, open circles here in numerical order. So -3, -2, 0, 2. Where you want to put them is fine by me. Again, -3, vertical asymptote, open circle. Then a -2, closed circle. Then a 0, open circle. 2 is an x-intercept, close it. Now we take care of our positive and negative regions. Right-hand behavior, positive x squared divided by positive x squared is a positive. Or if you look at all your x factors, positive times a positive divided by a positive times, all these are positive x's. So right-hand behavior is positive. And on every one of these circles, since they all occurred once, they alternate. Negative between 0 and 2, positive between 0 to negative 2, negative 2 to negative 3. That short little space there will be negatives. And then after the negative 3, we're all positives. Now we can put in our y-axis. That's their x equals 0, and that would be also our vertical asymptotes. And we can put in our horizontal asymptote, y equals 1 up here. So my vertical asymptote here, I made it a little thicker and darker because I wanted to put my y-axis right over the top of it. There's my horizontal asymptote. Now again, if we want to start making our graph, again, I like to start with the right-hand behavior. Here's the x-intercept like we had before. It has to go to the left from the 2, has to be in negative y's and approach this asymptote line. But now because this horizontal asymptote has been moved up, it's just going to go up towards the bottom side of that asymptote, and we'll put an arrow there. Now remember the rule on asymptotes. If I go down on the right side, it has to be going up over here on the left side, which is a good thing because here is a positive. Now, what we're going to do here is we're going to go from up here, we're going to come down, head towards that x-intercept, hit that point, and go through. And there's my graph there. So again, here's that skinny part that has all negative y's. Now again, remember on this vertical asymptote, down on the right, up on the left, down on the right side of this one, up here we got to be. So now my arc is up in this section of the graph. There's no x-intercept to go to, so there it is. And there's my rough graph of my rational function. Now, in my math lab, every once in a while, I'm not going to demonstrate it here, but I guess I could. Let me get my iPad out here. I have noticed that in some of the problems, they're going to ask you, where does the graph cross the horizontal asymptote? Okay, so let me move this over so I can reference this. So I need my function. There we go. So here we're going to answer that question. Where, well, that's an ugly H. Where does R of X intersect horizontal asymptote? So R of X, x squared minus 4 over x squared plus 3x. Intersect means they have to be equal to each other. So we're looking for this point right there. And so where is the y-coordinate of my green graph going to equal a 1? So my horizontal asymptote is a 1. So we'll solve this equation. So that's a binomial here. We'll multiply that to both sides. Cancels out. X squared minus 4 is equal to x squared plus 3x. Well, set it equal to 0, so I subtract over the 3x, or excuse me, the x squared. Getting ahead of myself, they both cancel. Negative 4 is equal to 3x. Divide by 3. So the intersection point is at negative 4/3, 1. So this point right here is at negative 4/3 for the x, comma 1. So that's how we can find where the graph crosses or intersects our horizontal asymptote.